Hello, engineers. Welcome to another lecture on the ongoing control system lecture series. So, in the last lecture, we had just introduced the course and the basics of it, nothing much deep into it. So, today I'll be giving you a brief review on signals and systems. I exactly don't know how many of you are familiar with the course signals and uh, my bad, signals and systems. So, so I will be just briefing you on it, like whatever are required in our course. So, one is what is a signal, like continuous time signal or discrete time. Then the systems. What is the system? What is system? Then in system, actually, I forgot to mention in the last class, what is the difference between a control system and control theory? Just a short uh, definition and realization on that control theory. Then on the systems, I will be briefing about the LTI system. Like this is the most beautiful property of the control system, like very important. So so without further ado, let's start with continuous and discrete signals. So what is a signal? Like if you find some Google, Wikipedia or something, like they will say any time varying physical phenomena that is intended to convey some information is called signal. Just forget about that. Signal is anything you want to convey, or signal is anything that carries some information. Signal is anything that contains some information. Like you say hi to someone or you shake hands with it. Those are all gestures and gestorical signals. So here we'll be mostly focusing on the time varying signals or time invariant signals, those stuff. So first is continuous time. What is a continuous time signal and a discrete time signal? So, so basically, what a continuous time signal is, as the you might have guessed from the definition, like if my signal is continuous over time, if it's my time axis and this is my x of t, so x of t is my signal, which is like t is the independent variable and x is the dependent variable. So I can choose, I have the freedom to choose whatever t I can take, and accordingly my x of t will be formed. Let's take a constant signal, like you will be like it's constant over time. Okay, so if I'm taking it as a, so for this signal I can say x of t is equal to a. So here my independent variable is time and my signal is valid over any point of time, like whatever I zoom, however I zoom, like this. So I can take any time and I will be getting some value. So what happens in discrete time signal is the dependent variable is an integer, not a time, x of n. So n is our integer, which is a independent variable, and xn is the dependent variable. So this signal is not valid over all the time. Like whatever integer we choose, according according to the integers, the signal will be like a same signal, the same a constant signal in discrete time can be defined like this, this, this. Like this is 1, 2, 3. It's a constant value signal. Like this is a. So in this course, we'll be more focusing on the continuous time signal. We won't be focusing much with much dive in. We won't be diving into the discrete time signal. So now comes the system. So system, like as I had forgot to mention the sorry, control system and control theory. Okay. So what control system is, like this is a diagram you will be so much using. Like this is our system. There is some input to the system, and there are some output to the system from the system. So the system can be anything. Like it's you can take as your grinder at your home, as a system. Like you plug this, it's plugged into the switchboard, and you when you give the input as the not available on it, so it will be like varying the speed, then accordingly it will rotate. Okay, so the output is the rotation, like speed, and the input is the simply whatever. Sorry, this is not the input. The input is the knob. And apart from this, another example you can take is simple system like a multiply, like into 5 plus into 5. Like whatever signal I give, like suppose I am giving 2, then I'll be getting 10 out of here. So now this into 5, like this, my system takes the input, whatever input it requires, and it just multiplies 5 with it. So what control theory actually says is control theory. This says if I want some particular output, if I have some desired output, then I need to strategize my input. Like I can't randomly give some signal. Like if my system is like sorry, whatever signal it takes, it just multiplies by 7. Just assume just the system, and I want my output to be 105. So what value of input I need to put so that I will be getting 105? So obviously I need to come up with 15. So, but this number 15, how did I end up on this? So this strategy, now I know like my system is just multiply, so I will just divide 105 divided by 7 is equal to 15. This strategy, it's a very simple strategy what I did, but this strategy is called the control theory.